ready residential parking.
Ooh, sorry.
Not to worry. I'm confirming everyone's still able to see the slides that I'm sharing. My screen's changed a little bit.
Yes.
Okay, good news. So just really excited to share with you the results of this new construction costing study. And I guess I should note at the outset that I'm joining you from the territories of the Musqueam, Squamish, and Tsleil-Waututh. And so we're out here in Vancouver, BC. AES is an electrical engineering firm that does sort of full service electrical practice. I myself am not an electrical engineer. My background's in policymaking and planning, and I've actually been a local government staff person myself for a number of years before I got into consulting. So for 4 years, I was sustainability manager at the city of Richmond, BC. And we were, I believe, the first, definitely in North America, maybe the world, to adopt 100% EV ready requirements while I was there. And so since then, I've helped, a number of cities with other topics, but definitely also with EV ready requirements. So excited to share some of that with you. So we're really grateful to get to work with CAP on this project. CAP is obviously supporting local governments in the GTHA that are considering EV ready requirements. So they commissioned this study, and it's worth acknowledging that this is generously supported by the Atmospheric Fund. And then we were certainly the primary leads in this analysis. We did bring on Mulvaney Banani International Inc., MBII, who have a strong presence in the Ontario market to provide sort of local design advising and peer review. So what I'd like to chat with today is kind of two broad parts to the presentation. Firstly, provide some key background information. So I'll do a really quick review of EV trends and policy context, and then speak about the importance of access to home charging to enable high levels of EV adoption in the future. Then I'll just describe exactly what we mean by EV ready parking and explain a little bit about EV energy management systems, which are an important technology to enable high levels of EV charging, particularly in multifamily buildings, but a range of other contexts, workplaces, community facilities and others. So, my apologies in advance if this is sort of covering material that some folks on the call are already familiar with, but I figured it would be useful for those that maybe aren't quite as steeped in this area. And then the second part of the presentation would be just a quick overview of the EV ready residential parking costing study that we performed. So I'll provide an overview of the 4 building archetypes that we looked at, the range of design scenarios that we evaluated for each of those archetypes, and then of course, the cost results. So in terms of trends and context, probably the most important trend in transportation is the decline in lithium-ion battery prices. So they've gone from about $1,200 per kilowatt hour of battery capacity in 2010 down to the best estimate for 2020 is $137 at the pack level. And basically what's happening here is there's learning by doing, there's economies of scale, technological advancement, and every time you're getting a doubling in battery capacity, manufacturing capacity for batteries, we've seen prices decline by about 20%, and that's held true for the last 30 years or so. Pretty much every analyst that looks in this space expects that to continue into the future, and that's going to fundamentally change the economics of manufacturing EVs. So this is work that was put together by the International Council on Clean Transportation, and it shows vehicle purchase prices. So it's basically the cost of manufacturing plus 15% profit margin for battery electric vehicles with various different ranges. So the top purple line here is EV with the 400 kilometer range, one with 300 kilometers range, and 250 kilometers of range. This lighter pink line at the top is a plug-in hybrid vehicle with 80 kilometers of electric range, and then of course also a gasoline drivetrain. And then that's compared to a conventional gas vehicle here in the brown. So what we see is without incentives over time, as those lithium-ion battery prices get down to about industry averages of $100 a kilowatt hour by the mid 2020s, it's going to be the same cost and then subsequently less cost to produce and presumably to purchase or lease EVs. And so at that point, you're going to have vehicles that are the same cost or lower cost than gasoline vehicles. They are going to be much lower cost to operate. They are much lower cost to operate. You know, driving an EV is the equivalent to about 20 cents a liter in terms of your fueling costs when you charge at home, based on typical residential utility rates in Ontario. They are much lower cost to maintain, so about maybe 40% of the cost of internal combustion vehicles. And, you know, it's a better driving experience typically, as well as being zero emissions. So it's difficult to understand, you know, a decade from now, why anyone would be purchasing internal combustion vehicles, provided that they've got access to quality charging infrastructure. So that's just, you know, the technology and economics that are driving those trends. We've also certainly got policy drivers. Importantly, the federal government in June announced that it would adopt requirements that 100% of passenger vehicle sales be zero emissions by 2035. We've seen sort of these same targets adopted by California and a number of other US states. There's efforts to have national regulations to this effect in the states. This was just recently adopted by the EU, and we've got a very similar sort of policy regime in China. So all the world's major auto markets are orienting around EVs, and we've seen commitments from manufacturers to do the transition to electric transportation accordingly. And that is really good news for the climate. So this is work again from the ICCT, looking at the life cycle carbon emissions intensity of gasoline vehicles versus battery electric vehicles, these two middle bars. So this third bar here is for EVs at North America's average grid intensity, and you see the error bars are between current policies of where we'll be 2021 to 2038 versus Paris compatible electricity mix. My guess is we're probably going to be closer to the Paris compatible mix, given how we've seen advancements in the cost of solar and wind declining. But in a jurisdiction like Ontario, you're already here where you've got predominantly zero emissions electricity. And so the full life cycle emissions of those vehicles, including the manufacture of batteries and other components of the vehicles, probably about 15% of gasoline vehicles. And there's tons of room for that to decline as well as we get lower carbon mining and manufacturing processes implemented, both for the batteries themselves and then also for the steel and other components that go into the vehicles. So we know adoption of EVs is important and really inevitable. We need to provide people with access to quality charging. So the charging pyramid is a good way to think about where households charge their vehicles. The vast majority of charging takes place at home. In Canada, the average is about 75% of all charging that occurs is home charging. So either in multifamily buildings or single family homes. Now, some households get away with level 1 charging, which is like a 120 volt outlet, similar to, you know, your typical wall outlet. But what we see most EV adopters wanting, and what's really going to be required for the larger EVs that are coming to the market, and that it seems like people do want to purchase these larger vehicles, is level 2 charging. So that's the same voltage as, let's say, a dryer plug or an oven, 208 or 240 volt. And it goes anywhere from 16 amps to 80 amps, and so provides varying levels of power there. So households want access to that kind of home charging. Workplace charging is about 15% of all charging in North America, and then the balance is in public areas. So workplace and public charging are I'd say important complements to home charging, but home charging really is the most important. That is a challenge because, well, in single family homes, if you've got an on-site parking space that you can park in, like either a parking pad or a garage, it's typically, although not always, relatively easy to provide EV charging at that spot. In multifamily buildings, it tends to be quite costly and complicated to retrofit that charging in after the fact. So we've had programs in BC for the last 5 or 6 years that have provided incentives for multifamily buildings to do retrofits. There's also been federal funding programs for about the last 2 years. What we're seeing is in that period, kind of the average cost per charging station is about $7,000, which is just kind of too expensive to really be scalable. Now, it is possible to get to, I'd say, significantly lower costs based on our experience in multifamily buildings when you do comprehensive 100% EV ready retrofits. That being said, it's really quite challenging to get condo associations and rental building owners to invest in those types of projects. They've got a lot of other demands for their capital, for their money. And understanding what you need to know in order to do those effectively is complicated. Owners lack expertise. And so you've got both the significant upfront cost barrier as well as just kind of knowledge and capacity barriers. And practically speaking, we're only doing, you know, a few of these types of comprehensive EV ready retrofits, and it's really difficult to get buildings to move in that direction without really strong incentives and policy support. So it's certainly best to future-proof buildings for EVs at the time of construction. EV energy management systems are a critical technology that enables high levels of EV readiness in multifamily buildings and in other sorts of applications like workplace charging or fleet charging. So what EV EMS is systems that monitor and control EV loads. So basically they're charging stations that have some intelligence to them and can communicate with one another or with you know, a management system that's located in the cloud by some kind of network. So it could be cellular, it could be a wireless network or cable in the wall. But the basic idea is that if, let's say in this diagram here, if one vehicle were there parking and charging, it would get the full capacity of this branch circuit and charge at a relatively fast rate. So in this case, that would be about 40 amps worth of power, and it could take the whole thing. But when multiple vehicles plug in and are charging simultaneously, the EVSE communicates both with the vehicle as well as with each other to ensure that they're not exceeding the capacity of that branch circuit, not tripping the breaker. So when those vehicles are charging simultaneously, they will be charging at a slower rate, but in certain applications, you know, notably home charging, when vehicles are parked there overnight and have a relatively long period of time to charge, that's perfectly all right. You know, the first household home might get there at 3 p.m., get fully charged up by 5 or 6 when the next 2 vehicles come back, and those can share that circuit over the course of the night, and everyone's fully recharged by the next morning. So what designing for the use of EV energy management systems allows you to do is significantly reduce the electrical capacity and associated electrical infrastructure costs that are necessary to provide EV charging. So it significantly reduces costs, and therefore you can accommodate greater amounts of EV charging within a limited amount of electrical capacity in buildings. There's a number of different sorts of electrical configurations that can make use of different types of EV charging infrastructure or EV EMS systems. So a common one, especially for multifamily buildings, would be this circuit sharing type of approach where you've got multiple charging stations that are sharing one branch circuit, and they just share across the capacity of that circuit. There's also panel sharing systems where you overload an electrical panel and then all the EVCs share the capacity of that panel. There's feeder sharing systems. You see these oftentimes in sort of single family home or townhome applications, or maybe some small apartments where households have their own electrical meter that's proximate to their panel. And what you do in this case is put your energy management system on that feeder from the meter to the panel, and have your charging station branch off from there. And what it ensures is that if the panel is approaching its limit, then it can throttle down or turn off, switch off the EV charging limit so that you won't exceed the capacity for the panel. Now, there are sort of other sorts of ways you could do this, having load switching, so have the EVSE actually off of a branch circuit off of the panel, or you could have the EVSE and, let's say, a dryer share the same circuits. And so you'd say, or share the same power allocation. So you'd say either your EV charging can be occurring or your dryer can be on, but not both. And that avoids overloading your panel. And that's perfectly all right, because usually we don't have our dryers running all through the night. And so there's going to be plenty of hours there for the EVs to be charged. One last sort of EV energy management scheme that's important to understand is service monitoring. So with service monitoring, you've got your management system actually monitoring the main service into a building, or maybe a main feeder within, let's say, a multifamily building. A feeder is like one of sort of at the base units of your electrical systems that's going to be providing power to different parts of your buildings. And so it's monitoring how much power is being consumed by the building in real time, and then sending signals to your charging stations that, yep, it's okay to charge, we're not close to the building's limit, or no, you need to throttle back. And what's useful about that is it allows you to take advantage of additional power that's available in the building. So in this diagram, you've got your sort of building load without any EV charging here at the bottom. And so it usually sort of peaks around 6 p.m. in residential buildings. And there's a lot of capacity in the middle of the night as well as in the day. And typically buildings, well, almost basically all the time, buildings won't use the full capacity of their building. The electrical code is inherently conservative, so there's tons of remaining capacity up there. So if you don't use these types of systems, according to the electrical code, you would only have the capacity between what would be the peak of the building and what the building's transformer capacity is to use. But if you're using service monitoring energy management systems, then you can use all that remaining capacity that's below that peak line. What this allows you to do is design buildings according to the electrical code, to exceed, to have more EV demand and avoid things like a service upgrade or a transformer upgrade that would otherwise potentially cost developers a fair bit of money. They can instead plan to implement service monitoring if they're approaching the capacity of the building, so that they would be taking advantage of this space underneath here. Now, practically speaking, most buildings, the absolute maximum demand they have is maybe 30, 40, 50% of the transformer capacity. And so it's not needed. So new construction, you can say, look, we're able to install service monitoring, but it won't actually typically be needed for a multifamily building, but you've made provisions to allow it to be installed. So in terms of what we mean by EV ready and how local governments have typically structured these requirements, EV ready basically refers to all the electrical capacity necessary up to a junction box on a branch circuit to install an EV charging station in the future. So it's not installing the charging station, it's just having this outlet that you can hardwire a charging station in, or potentially plug one into in the future, and the requisite panel capacity and properly sized switchboards and transformers, of course, to accommodate that EV charging demand. So that outlet can either be a junction box that you would hardwire a charging station to in the future, or in some cases a receptacle that you could just plug a charging station in. Now, in terms of the local governments that have adopted 100% EV ready requirements, since we did this in the city of Richmond in about 2017, there's now, I believe, 17 communities in BC that have adopted either all residential parking needs to be EV ready, or there's a few that have adopted at least one EV ready stall per dwelling unit. Toronto's likewise made a commitment in its EV strategy to reach 100% EV ready residential buildings, and I believe they're consulting on that right now to update the Toronto Green Standard to reflect that. And we're also speaking with and working with a number of other municipalities across the country, as well as jurisdictions in the States, looking to implement these sorts of 100% EV ready requirements. And I would note there's already a number of communities in California that have also done something similar. So this is kind of a made in Canada best practice that's, I think, really picking up international steam and being adopted both in North America as well as around the world. We've got similar sorts of requirements in Chinese cities, in Oslo and other progressive locations. Now, an important part of EV ready requirements are EV charging performance requirements, which basically say how much load sharing you can get away with if you're designing for the use of EV energy management systems, and how much power you need to be providing to each vehicle once all those vehicles are EVs, once all the parking spaces are occupied by EVs. So how much power EVs needs to charge really depends on how far they drive. So we were really grateful to get data from the University of Toronto's data management group. They administer the Transportation for Tomorrow survey for GTHA local governments. And the survey has basically trip diary information for how far individual vehicles drive every day over the course of the time that this survey occurs. And we can map that onto geographies and say, for different planning districts in the GTHA, this is how far vehicles travel on average per day. So you can see where most of the multifamily development is occurring in the region, not all of it, but most of it. You're probably not exceeding about 45 kilometers traveled per day on average, although of course it'll range from vehicle to vehicle, but we're averaging about 45 kilometers per day. So we have, over the last couple of years, developed models that consider the VKT data, as well as other factors, notably your average vehicle's efficiency, the vehicle mix's efficiency, temperatures, so how cold it gets in the wintertime, which can affect both your battery performance as well as how much heating the vehicles need, and so reduces vehicles efficiency, and also things like conservative estimates of arrival time and departure time. So we say, well, households are arriving, all of them at 6 p.m. and departing by, or I guess in this model, 7 p.m. and departing by 6 a.m. the next morning. So that's our window of time to charge. And what the model is solving for is basically how much sharing you can do on a branch circuit of different amperages, while ensuring that those households will have enough electricity for the next day's driving 99% of the time, and be fully charged at least 90% of the time for the next day. And this table is what it produces after, all's said and done. So for a given average amount of vehicle kilometers traveled, what's the maximum number of EVs that could share these branch circuits of given sizes? So for instance, we found, and are quite confident with this result, that you can get away with 4 share on 40 amp circuits and still have a really good charging experience in much of the GTHA. Likewise, you could get away with 10 share on 80 amp circuits. It's worth comparing that 4 share and 40 amp circuits to what's currently in the Toronto Green Standard version 3. So right now, the version 3 says that charging systems must be capable of supplying a minimum performance level of 16 kilowatt hours per EVSE over an 8-hour period if all parking spaces are in use. So that allows for 3 share on 40 amps or 6 share on 80 amps. And we're saying, well, it is actually possible to provide really good qualities of charging services while allowing for more sharing. So this would be sort of the maximum extent of sharing that we'd recommend be allowed. Now it varies depending on how far households drive. So in communities that are more exurban, they may want to have somewhat more stringent performance requirements. So let's say if you're in a community where the average daily VKT is 70 kilometers, very exurban communities, maybe you'd only want to allow 2 share or maybe 3 share on 40 amps. I will note that what our model is assuming is that all charging is provided in an at-home context. I think certainly 20 years from now, there will be workplace charging. There will also be convenient, publicly accessible charging. So households will have other options, and that'll eat into how much power is actually needed to be provided at home. So more exurban communities could reference, let's say, this requirement for that's sort of established for communities where there's an average VKT of 45 kilometers, just with the expectation that households will be using significant amounts of other types of charging. So just provide some screenshots of basically what the model is doing. What it's doing is looking at each vehicle and saying, okay, here's the amount of charge that's in the battery. So this is its maximum charge level here. You see the blue line at the highest value it gets to. And here's the amount of charging power at any given time that the vehicle's taking. So it's parked and charging, and in some cases sharing with neighbors who also happen to be parked at that time. And you can see that the vast majority of evenings, it's getting fully recharged. There is one point here on, I guess, the night of March 21st, where the vehicle goes a very long way in the course of the day, and it doesn't get fully recharged. It gets back up to about 80% charge that night, but it is absolutely enough to meet the next day's driving needs, and then it gets recharged again for the following day, and it's recharging every night. So this graph shows, based on the model that looked at a whole range of different vehicles, like 28 in total sharing a multifamily building, what percent of the vehicles are not fully charged over the course of a year of simulations. So the overall number of vehicle days here would be about 5.5% of days out of the year. You'd wake up and go downstairs and find your vehicle's not fully charged. It maxes out at about 30% of days where everyone's coming down and finding their vehicles not fully charged, which is more common in the winter because it's colder then. This graph shows those percent of the days where households would need to augment with some other form of charging. So maybe workplace charging or on the go opportunity charging at a grocery store or something. So 0.1% of vehicle days, you can't meet those driving requirements. You won't be able to get where you need to go for your next day's worth of driving. So one day out of every 3 years or so, a household would need to augment its charging if you're doing 4 share on 40 amps at a 45 kilometer per day sort of design scenario. So again, these would be our recommended EV charging performance requirements that can be referenced in EV ready requirements in most communities in the GTHA. So now I'll switch to speaking a little bit about the costing study for the second half of my remarks here. So the process here is that we have a whole range of different building archetypes. We looked at 4 different archetypes for this study. And then we do electrical load calculations for those archetypes. So we look both at a baseline building that has no EV charging infrastructure in it, and then a series of EV charging configurations with different levels of EV ready parking, as well as different electrical configurations using different EV energy management strategies to provide EV charging. And then we do electrical design, so single line diagrams that outline what electrical infrastructure needs to be in those buildings, and layout drawings showing for a given parking area what the lengths and geometry of the runs will be to provide charging to the parking spaces. And then based on that electrical design, we do costing. So this pulls from RS Means. That's a database of costing. The analysis was done for March 2021 costs, so it reflects the recent increase in costs in construction. You know, there's been significant inflation recently, and it's kind of capturing that. And it says for all the different electrical components that we need to upgrade from no EV charging infrastructure in the building to providing EV charging infrastructure, this is what's included. And then we report out on that, of course, what those incremental costs are and how they're divided between different components in the building. So I'll just give you an example here of one of the scenarios we looked at. We have a mid-rise building with a scenario that had 4-share on 40 amp branch circuits with that service monitoring EV energy management control I mentioned. So here in the single line diagram, we've got the service in from the utility. We've got monitoring of the main service of the building that can then control EV loads if necessary. And then we've got a transformer that transforms power from 600 volts down to 208 volts that's distributed to a series of panels that are located in different parts of the parkade that go out to branch circuits, each with 4 outlets on them where you can install charging stations in the future. And this is just an example of that same building with those wiring runs out to each of the parking spaces in the building. And then this is an example of what the costing looks like. So we've got the transformer and EV distribution board breakers here. So you have to install this equipment to be able to provide power for your EV charging. We've got a whole range of equipment feeding panel boards and then having branch circuits out to each parking space. And we've also got communication systems in here, which make up a not negligible component of the cost, 27,000 out of total incremental cost here of 194,000. These communication systems, in this case, for all the scenarios, we were assuming cellular communications. Worth noting that a lot of the times buildings might put that in regardless, just to provide cell service in parkades. But kind of a conservative component to this is we're saying, well, that is an incremental cost to enable the EV charging. And that gives both your total incremental cost from doing nothing to this 100% EV ready building, as well as a cost per parking space here in the bottom 2 lines. And we also did an analysis that applied multipliers to each of these items to basically indicate how difficult they would be to retrofit later on to provide EV charging. So it's a fairly coarse analysis by necessity. I think what it reflects is kind of a ballpark estimate of what the cost would be to incrementally add some EV ready parking spaces over time. We have found in practice that if we were to do this all at once, it typically is possible in existing buildings to do 100% EV ready retrofits at significantly lower cost points than this $6,000 per stall. It still will certainly be more expensive than doing this for new construction, but it is possible to do comprehensive retrofits. But for the way most buildings have done this to date, sort of one-off implementations of a couple of EV charging parking spaces, it's kind of a reasonable ballpark value that can demonstrate the importance of future-proofing this parking. So this is a summary of the 4 archetypes that we looked at. We had a high-rise, mid-rise, townhouse, and single-family home. So the high-rise was 16 stories, 405 units, and it had 369 residential parking stalls, as well as 61 visitor. Now, we didn't make the visitor EV ready. We just assumed the households assigned parking is going to be EV ready. In the mid-rise, 7-story building, 151 units and 119 residential stalls. And then the townhouse is 19 townhouse units organized into a number of different sort of townhouse complexes, each fed by a utility transformer. And each of those townhouses had a private parking garage associated with them, with like each of those units. So 38 residential parking spaces in total. It's a 2-car garage. So each of those units had a 2-car garage. And single family, likewise, it's a single family subdivision with 22 units. And each of those single family homes had a on-site 2-car garage. And then I'll just walk you through each one of the scenarios that we looked at. So apologies that there's, these series of 4 charts, but it's kind of the most simplest way of conveying all the different scenarios that we did designs and costing for. So we've got the first column here, just numbering the different scenarios for each of the different building archetypes. So here we've got the high-rise ones and scenarios 1 through 7. And then this description of the electrical configuration and EV energy management system that's been implemented. And then here in the third column, the percent of parking spaces that are made EV ready. So the first 2 scenarios were meeting the Toronto Green Standard version 3 requirements that 20% of parking be EV ready. And we looked at scenarios both with dedicated 40 amp circuits. So you just have one 40 amp circuit to each EV ready parking space, as well as a 3 share on 40 amp, which is allowed under the TGS version 3 to do sharing of that nature. Then the remaining 5 scenarios, C3 through 7, are all 100% EV ready scenarios. The first one is dedicated 40 amp circuits. Then we've got a 3 share on 40 amp, so meeting the current TGS performance requirements. And then 4 share on 40 amp and 10 share on 80 amp, both of which meet the performance requirements we analyzed could be used, as well as a 4 share on 40 amp with service monitoring. So also meeting those performance requirements and having that service monitoring to avoid any kind of transformer upgrade and utility service upgrade that can be costly for developers. So the high-rise scenarios were fed by primary distribution voltage. So for the high-rise scenarios, we considered locating the building both in Toronto Hydro's service area as well as Electra utility territory to reflect that they've got different primary distribution voltages. So the electrical systems look somewhat different between the 2. And then we've got the mid-rise scenarios. These were the same electrical configurations. You can see here the 20% EV ready for the first 2, and then the same 100% EV ready scenarios. Just worth noting that for both mid-rise and high-rise and all of these, like these aren't the only options that you could do to be compliant with 100% EV ready. There's a whole range of different sorts of strategies, but we see these as being likely sort of directions that developments might want to take. And then for the townhouse scenarios, the first one is 2 share on a 40 amp circuit. So in that townhouse development, you've got one branch circuit from the townhouse's panel that goes to the parking garage, and households would charge their vehicles from that. So if you've got 2 EVs in that garage, you either just are unplugging the charger and putting it into one vehicle one night and the next vehicle the next night, or there's certainly dual-headed charges if that's what households want to install. So this scenario would require both upgrading the service to buildings as well as upgrading panel sizes. We conservatively estimated or sort of designed, which is the practice today for 100 amp panels. Well, the practice today for, a not insignificant proportion of developments to have 100 amp panels in townhomes and also some single family homes. So we assumed those 100 amp panels. And to do this, you would be both a upgrade to your utility services to each of the townhouse complexes, as well as increases in the panel sizes. So we looked at a scenario that would have service monitoring that allows you to keep the same service size. So basically for a transformer that's feeding multiple different townhouse units, you've got equipment on that service feed, and then households through some kind of strata rule or bylaw, condominium rule or bylaw would need to only implement charging stations that are compatible with that energy management strategy. And then here with load switching, basically you've got equipment that says, okay, your dryer can be on or your EV charger, but not both. And that allows you to avoid upgrading from a 100 amp panel to the next highest panel capacity, 225. And then finally, for the single family subdivision scenarios, we've got, again, just sort of a 40 amp branch circuit off of your panel. And that requires you upgrading from 100 amps to higher amperage panels, and then including service monitoring. So you don't need to make that upgrade. I will say, you know, these are sort of inherently conservative scenarios because they were assuming that for these single family homes, you'd have 100 amp panels. Now, I think in addition to transportation electrification, we're going to need to see movement towards electrifying other aspects of building systems. It's possible to do that in some homes still with 100 amp panels, but usually you'd have you know, an increase in the utility services, potentially some increase in cost there. But then, of course, you're also saving on connection and to gas services and gas plumbing as we move towards electric sorts of building systems. And some homes would certainly have 200 amp panels already. So we're kind of looking at sort of the toughest case scenario here from just a strictly transportation electrification perspective. Typically, although I guess not all the time, but usually if you've got a 200 amp panel in the building, you can just do sort of a simple branch circuit from that panel to EVs without any kind of EV energy management, and the cost is very small. So in terms of the results, here's results for the high-rise and electric territory. This graph is showing the cost per EV-ready parking space. And so for the first two, the cost per EV-ready space is noted here. Now, of course, the total cost will be less because only 20% of the parking spaces are EV-ready. And then we've got these subsequent scenarios. So I think, you know, from a policymaker's perspective, it's useful to look at the lowest cost types of scenarios to say, well, we want to ensure that buildings are able to implement this, which it's certainly a viable design strategy. And we then can say, like, well, this is a reasonable estimate of what it could cost you as a developer to implement this type of infrastructure. So C7 here, we see 4-share on 40 amp branch circuits using service monitoring. So you're designing for service monitoring to be able to be installed and avoid the capital upgrades to your utility service and to the building's transformer. And for the high rise, that was costing around $1,700 per EV-ready parking space. For mid-rise, again, you can see there's ways of doing 100% EV-ready that are ranging between about $1,500 and $2,000 per EV-ready space. For this scenario, the sort of lowest cost strategy is sharing 10 parking spaces on 80 amp circuits. So that was around $1,500 a parking space. It's worth noting that right now there are relatively few EV charging service providers that can serve this type of building, although they're definitely out there. What is required under the current rules in the building code, if you're going to do this, is either to have 80 amp chargers, which would be relatively more expensive, or to have an integral circuit breaker in the chargers, which most of them don't currently have, and products would need to be reapproved, which is why all the manufacturers just haven't gone out and done that. That would be a fairly low cost addition, but it's just kind of the challenge of getting reapprovals for products. Or we could have a change in the electrical code. It is safe to have 40 amp EVSE on 80 amp circuits. We're doing that with special permissions on a couple of different projects. So that's a viable design there. And I think there's going to be a lot more systems in the future that'll be able to make use of that kind of design strategy. And then in the townhouse scenario, the lowest cost way to do things would be not have service monitoring, but use a load miser. This is this piece of equipment that basically, again, lets you switch between your dryer being on and your EV, and that'll cost just a little bit over $1,000 per EV-ready space. And finally, in single-family homes, at around, I think it was $850 per space, $830, using service monitoring. So a product, if folks are familiar with it, might be what we were costing for here would be the DCC RVE9 sort of product that is monitoring your panel's capacity in real time and allowing for allocation to your EV charging accordingly, as long as that panel isn't approaching its limit, which very, very rarely happens. So that would cost around $870 per EV ready space. Again, if we look at buildings that have higher amperage panels, the costs are going to be significantly less than this a large majority of time. This is kind of an inherently conservative scenario. And lastly, this slide just summarizes the analysis for one of the archetypes, our high rise with 4 share on 40 amps with service monitoring, comparing the cost of doing this for new construction versus a series of incremental retrofits in terms of the cost per EV ready space per parking stall. So you can see there's going to be significant life cycle savings just to do things right from the outset and make all parking EV ready versus having condominiums trying to coordinate these kind of complex and more costly retrofits over time. So thanks very much. Hope that's useful and looking forward to a conversation here.
Thanks so much, Brendan. Really appreciate all that. I will throw it out to the audience for questions that you have. Just you can raise your hand. You can put your question in the chat. You can also just unmute and ask your question. So I'll leave it a couple of different ways for you to ask your questions. I'm okay with the awkward silence. I know you have questions.
I have a question, Gabby, for Brendan.
Go ahead, take it away.
When you did your cost analysis, you included, I guess, the infrastructure. But does that assume that there is already existing proposed infrastructure? In other words, a typical building would already have a transformer vault, electrical panel. Is your costing then in addition to that for the EV infrastructure?
Yeah. Thanks, Edward. It is the incremental cost over and above the building that has electrical systems in it, of course. But what additional sorts of equipment you would need to add in the building to provide those EV ready parking spaces. So the building would have let's say a transformer. If there needs to be a transformer upgrade to a larger size, that's included. A building without an EV charging infrastructure won't have any panels located throughout the parkade or wiring to different parking stalls in the parkade. So it's all those incremental costs. It won't have, switchgear might be sized differently. You've got an additional feeder. So it's all those kind of incremental costs and incremental infrastructure that needs to be implemented to provide EV charging in the parking spaces.
I have another question coming in the chat. Towards the beginning of your presentation, Brendan, you mentioned that EV charging will mostly happen at home. For example, in Canada, already around 75% of charging occurs at home. Would you happen to have a data source or reference that supports household wanting to charge at home versus elsewhere?
Yeah, I mean, when you look at the Charge the North study, it finds that 75% of households in Canada are charging at home, so they followed EV drivers. There's been survey work, and I will see if I can send Gabby some of that just documents what is quite obvious to anyone who has an EV, drives an EV, that home charging is considered by far the most sort of convenient type of charging, and households typically want it before they adopt EVs.
Perfect. And then another question from Matthew is saying, so these mandatory requirements of EV ready buildings are being pushed through city bylaws. I'm working with the city of Regina right now for a renewable city strategy, and really pushing for an EV charging strategy that covers this type of content. I can answer that, Brendan, if you want, in terms of the consultations we've done with municipalities thus far to better understand the levers available to municipality and the different pros and cons associated with it. So the general thinking thus far is that there's two places for municipalities to enact in order for them to put in EV charging requirements in new builds. The first one is obviously in the terms of the city bylaws in terms of parking and the zoning requirements on how much parking requirements are. So that's one area that there's the lever available to municipalities to advance EV requirements. The second lever is within their green development standards, the Planning Authorities Act that provides them with those authorities that you can do it in your green development standards. Now, while we are still in the early stages of the consultations on the pros and cons of different approaches, the pros of the green development standard is that if you have a green development standard, it is a very relatively easy opportunity to put an EV requirement metric into that green development standard. However, there is a lot more authorities that are provided as part of zoning and bylaws that municipalities have. So a stronger authority is in parking requirements, but often a lot of times municipalities parking requirements and zoning are challenged more often from the development community than green development standards are. So those are some of the initial thinking thus far, but both of them are avenues available to municipalities for advancing these EV requirements in the new build sector. And
thanks, Gabby. And if I can just build on that a little bit, Matthew, for your work in Regina, in BC, all the municipalities have done this under their authority to regulate parking. So local governments have authority to regulate parking pretty much, in every province across the country, and that's tended to include parking design. So you can say parking will be designed in this way. It'll be X dimensions. It'll have this sort of lighting at it. It'll have this sort of paint. And so in BC, what the communities have said is we can make provisions for EV readiness in those requirements. And because there's no provincial requirements that are in place, it's been their opinion that this doesn't run afoul of like concurrent jurisdiction issues. So I think for Regina, you could both do this kind of potentially as sort of a policy approach where it's going to be a consideration of rezoning or development permits. I think also it's worthwhile looking at having this within your parking requirements, which are either located in zoning bylaws or in standalone parking bylaws, just because it makes it more predictable for developers and for city staff. Now, I suppose you could also explore whether or not you have authority, like under your charter, to make that in building code requirements. Vancouver originally had these sorts of requirements in their building code, and then they switched it to their parking bylaws because it is sort of administratively more straightforward, and also the parking bylaws better set up to allow for different sorts of requirements for residential parking versus different types of non-residential parking, whether it be like office with like a high proportion of workplace parking or retail or what have you. So that's some of the background there. I think it's worth conversations with your planning staff and certainly your city legal departments, but communities in BC have been happy to put this into their parking bylaws. Yeah, I'll leave it there.
Perfect. And that is one of the to-dos on our list coming out of this, is to speak with municipalities and their parking folks as well as their planning folks to try and figure out what do you think is the pros and cons from your own municipality's perspective on where you can apply these, and then kind of highlighting and documenting the leading practices, but then also the different pros and cons and questions that a municipality may want to ask themselves so that they can determine what fits best for their jurisdiction. Another question that came in, Brendan, you mentioned that the cost multiplier you found for retrofitting EVSEs in the mid-rise example versus providing them in the original, in the time of construction was the definitely higher for the retrofitting. Are you able to elaborate on what the multiplier would be for other building types? Or what the range would be to expect the multiplier to fall? Let's say, for example, in the single family or the townhome, or the factors that increase the retrofit costs that people may want to know about?
Oftentimes for single family, it will be considerably lower. So typically putting in EV charging after the fact isn't a huge deal if you do actually have on-site parking for that single family home. That's not an argument for on-site parking, by the way. It's just, you know, that's the facts. For townhouses, you can sometimes accommodate just some EV charging in that townhouse. A challenge is if you actually get multiple EVs in there, which we will ultimately, then you could potentially wind up overloading the building's transformer. So it can be complicated to have EV charging systems that'll work for townhomes once everyone's got EV charging in those buildings. And so there could still be significant multipliers there. And then for townhouse and high rise, it is very complicated to retrofit those buildings effectively. So the multiplier for townhouse, or sorry, for mid-rise and high-rise and townhomes for our like rough analysis of that kind of multiplier was similar. It would average out to about 3 times more expensive in kind of an incremental retrofit context. Now, there may be ways to do comprehensive 100% EV ready retrofits. There typically are ways where you're not going to see it being quite that expensive. It's just that condos usually aren't, especially without sort of supportive financing and incentives, able to or willing to make that sort of comprehensive retrofit to kind of replicate the future-proofed infrastructure that we're proposing here for new construction. They tend to add this more on a piecemeal basis, at least in the early years, which is going to be much more expensive on a life cycle basis. I will just note that in BC, this was based on some work we did designing this program, but BC now has the first 100% EV ready incentive program where we have funds to help buildings first make an EV ready plan. So it's like an electrical assessment and then schematic design sufficient for budgeting purposes to retrofit buildings to make all the parking EV ready. And then incentives of $600 per parking space, up to $80,000 for the building to help those existing buildings be EV ready. So it's a good way to sort of build, I guess, the market for those types of services. It's no substitute for, you know, kind of stemming the bleeding and getting new construction right and having them be 100% EV ready. But there are sort of solutions that we can look at to try to make large proportions of parking in existing multifamily buildings EV ready and future-proof for EV adoption that over the life cycle of that building are going to be a lot more cost effective than kind of the incremental approach that currently predominates. So I hope that's kind of helpful context there in terms of the multiplier and just kind of the issues that are faced by these buildings.
Perfect. Thank you, Brendan. I will turn it over to Mark. I see you have your hand up.
Yeah, thanks very much. Just as we're talking about these retrofits and levers that we can pull and incentives that we might put in place, these are all great ideas. I'll tell you that here in Ontario, we do quite a bit of this. The day that the Condo Act changed and gave some right to the owners and the residents to be able to ask for EV charging and gave them just a little bit of power in the back and forth, the difference was enormous. It's helped that we've had more vehicles and it's seeming more obvious that it's something that's needed anyways. But the fact that they're feeling that there's a timeline and giving some opportunity to owners to have a say in what's going on has made a big difference. And somehow or other, once it happens, the boards are more open, they're more positive when we speak to them, and they're seeing it as an advantage for their buildings. So the whole conversation changed, and I know that it's not a lever that's really open to the municipalities, because of course it's an Ontario regulation, a provincial regulation. But where this kind of thing is possible, you know, there's a little bit of the, you know, whether it's a stick or a carrot. Sometimes we have to look at both sides of the coin, and I'm telling you for a fact it's made a difference.
Right.
I'm glad to hear that, because I have heard, while it has been proved the situation, the right to charge legislation has made it easier for getting these conversations in condos and then with the condo boards. I've still heard from a number of people who are like, oh my God, that was a terrible experience of trying to get their condo to enable them to have EV parking. So I'm glad to see that it's made some improvements.
It has. It's truly, it's not a panacea. And if the board decides to put that they're just not wanting this to go forward, there's a lot of little pieces that they can do to make it very, very complex and difficult for you. But the conversation's changed, and I'm not seeing nearly as many of those as I used to see.
Good to hear.
Thanks.
Brendan, anything you wanted to add with regards to that, or?
Just that my distinct impression of like the right to charge provincial legislation is that it has given early EV adopters who really want that home charging sort of more leverage to be able to say, hey, I'm willing to pay for that infrastructure to be implemented and get charging either in common parking or in my assigned parking stall. It still does require that those households, and oftentimes they're helped by incentives at this point in time, be the ones footing the bill, and it's not the condos that are footing the bill. Those incremental approaches will tend to be a lot more expensive than if we can get condos to think, hey, you know, EVs are coming. There's going to be a large proportion of households within the next decade that are going to adopt an EV. So let's not just plan for the first couple of adopters, but future-proof the whole building. So I think once you get sort of the new construction regulations and regimes in place, I'm getting sort of ahead of ourselves in you know, what I'd be advising you to do. But the next step after that is figuring out how we're going to support these existing buildings to do more cost-effective and sensible retrofits at scale, because there are ways to do this that are relatively more cost-effective than the current sort of model and are ultimately going to be more scalable.
Yeah, definitely the incremental approach of like doing it one stall at a time and leaving it up to the owner to manage all of that is not the cheapest way to go about doing this.
Yeah, and it's, you know, more for the real sort of bought in, as opposed to people who are, you know, just trying to solve their problem. I don't think it's something that your typical household that isn't really bought into EVs is going to want to take on.
Perfect. I see, Mitchell, you have your hand up.
Yeah, just gonna ask a question about whether or not you looked at things associated with, say, the multi-unit residential buildings and what makes some installations more costly to do than others. So things like how old the building is, or what type of parking structure they have, whether it's above grade or below grade, and maybe even the number of units that go into that kind of unit, and distributing the costs out across multiple units because of the economies of scale. I don't know if that's something that you would have discussed as part of that study you did as well.
This study focused purely on new construction. So we were just looking at sort of costs for those archetypes to provide some indication of the types of costs that you could expect this would entail for new developments. I would note, you know, like it is just looking at the cost. We didn't make any sort of assessment of how much value this provides. Now, it provides an awful lot of value to the occupants. And I think developers can, you know, in our experience, some of them do a good job of like valorizing that value as well, right? This makes buildings, for good reason, more sort of attractive if you're going to build parking. And I think we need to be moving towards more developments that have less parking, like the cost of structural parking in these multifamily buildings and apartments is really high. All that sort of structure that's in there, it might be $40,000, $50,000, $70,000 per parking space to provide the structure. So the incremental cost of making it EV ready for $1,500 is relatively modest. But if you're going to have parking in there, we need to provide people with the opportunity to choose EVs for their vehicles, because providing parking does induce people to drive. So there's that kind of value there. We weren't looking at sort of what it takes as part of this study to do, like what are sort of the key factors that make retrofits more or less cost effective. I'd say generally, we've found in the experience in BC at least, that a whole range of buildings, it's possible most of the time to provide 100% EV ready parking. We typically try to maximize the opportunities to use EV energy management to keep costs down. If there is surface parking, doing sort of the trenching up of that surface and putting in that charging infrastructure can make it cost prohibitive. Likewise, just it depends building to building. It's hard to predict up front, but depending on like the geometry of the parkade and whether or not, and where the electrical room is, whether and to what extent you're going to need to drill through, like core through concrete, that can certainly impact costs. So it's difficult to make sort of predictions based on the types of buildings. In our experience, you just need to go in there and do an assessment to understand what it's likely to cost.
And thank you. Thanks for that, Brendan. So one of the questions also is looking at it from the integration of renewables for cost reduction and energy efficiency measures and how that might fit in for EVs. I'll take the first kick at the can, and then Brendan add in anything that I might have forgotten on that one. So we didn't have within the scope of the study of looking at different ways of meeting that. It was simply about the actual cost of infrastructure for EV readiness within new builds. So we didn't identify anything related to like how that electricity is met. It's just the electricity and how much it's going to cost to actually allocate all of the infrastructure for the EV readiness. Having said that, before we started this project, when the EV requirements were taken out of the Ontario Building Code, we did do some initial consultations with the development community to understand what was their resistance to the EV requirements within the Ontario Building Code requirements, and learned a lot from that kind of, from their insights on that one. Some of the key barriers that they identified related to that is that the OBC, the Ontario Building Code, requirements didn't bring energy sharing across EV chargers into consideration in their design. So as such, it was dedicated circuits for EV charging. That adds a lot of costs to it associated with it, not only from the perspective of the EV chargers themselves, but largely from the electricity allocation that the building needs to have in order to ensure enough electricity supply for those, and the modeling that was encouraged. It was kind of assumed that all of these chargers will be dedicated circuits and all being charged at the same time, which we know in reality is not the way this is likely to play out in the real world. So what it meant is that it wasn't simply the cost associated with the electricity infrastructure, EV charging infrastructure that was the concern from the developers. It was the total amount of electricity allocation. So that was one of the things we did learn from that experience on that one. And the reason that the Ontario Building Code didn't take in energy sharing into consideration was because there wasn't electric code standards at the time of the OBC adoption of those EV requirements. That has subsequently been changed. There are electrical code requirements for EV or standards for EV charging. But that was what definitely thing. Anything that is done to reduce the electricity allocation that needs to come from the grid into that building will be a benefit, because allocating the peak electricity loads is something that's a very it's costly for a lot of developments. And in many cases, it is completely oversized just to be on the safe side, in the sense that, electricity engineers are not necessarily willy-nilly on this. They really need to be careful on this stuff. And they often have a lot of buffering that they put into their models to ensure that they're not going to put themselves in a position where the building doesn't have the electricity it needs for overall functioning. So definitely, we didn't look at it as part of the costing study, but it is something that's going to be of real big benefit. Anything that reduces the electricity allocation in terms of energy efficiency and in terms of on-site renewables contributing to that building's electricity will be of benefit and only add to the business case of EV charging allocations. Brendan, anything you want to add to that?
Yeah, I would just add to that, and I hope I'm getting your name right, that as Gabby noted, we didn't look at including as part of this analysis any sort of solar and on-site storage. You know, I think that probably the most important priorities for local governments to think about are enabling electrification of transportation. So if you're building parking, ensure that you're allowing for EVs to charge in that parking, especially in residential, but also think about appropriate provisions for commercial, as well as moving towards electric zero emissions mechanical systems in buildings. So electrifying space heat and hot water, particularly in Ontario, where you've got such low carbon power. That being said, I think there is, I mean, certainly there's definitely a role for building scale renewables, notably solar PV. And it's just trying to think about what are the right kinds of regulations to make that happen. You know, California has gone towards these requirements that new developments need to have solar implemented. It does increase the cost of construction, but there is value there certainly for the ratepayers over time who are going to have lower cost electricity bills. So I think, you know, there's definitely a role for thinking about, do we want to start requiring some solar, both in terms of like reducing electricity costs, and then also thinking about appropriate type of, you noted like redundancy measures, but I think you can think about it that way also, like resiliency, just how do we keep core loads in buildings on through building scale solar energy is a really important thing for us to start thinking about how we make elegant requirements to make that happen. So, you know, I'd encourage you to keep sort of asking those questions and getting some essentially study and evaluation of what are the best ways to make that happen. But it isn't something that we looked at as part of this analysis, and I wouldn't be able to, you know, comment on what the definitive impacts are.
Perfect, thank you. And I'm just going to read a couple of questions on this one, just before I hand it back to you, Mark, for a question on this one, just because I want to get through the chats that people put in earlier. Brendan, I'm not aware of it, but I was wondering if maybe you might be aware of it. Do you know of any studies that have been done to kind of quantify the benefit to the local economy regarding shops or restaurants from municipal public EV charging?
Benefits to local economy.
Like just increased sales or anything that's been tracked in terms of increased sales from private businesses actually installing EV charging to get more and then getting more customers.
Yeah, I apologize. I'm blanking on the name of the study or the outfit that did that, but there has been work showing that, yeah, there is definitely, at least right now, this kind of impact for sort of local retail economics of providing that kind of public EV charging infrastructure. I'd also note, you know, like a really important consideration for local economic development is like import substitution. So right now, let's say in like the GTHA, every year households there probably spend, you know, what is it, $3,000 a year on average for the household in gasoline costs, and the vast majority of all that spending leaves the community. As EVs get more affordable, we're going to have a situation where you can enable EV adoption, and instead of spending $3,000 a year on gasoline, you'd be spending $500 a year on electricity as a household with two vehicles. That electricity spending is going to stay in your local economy more, and the $2,500 you've saved is more likely to be circulating locally. so because you tend to spend for the next thing that you're going to spend money on more on your local economy compared to gasoline, where the vast majority of that money leaves your municipality, leaves the province. There's been great work on that by what are they called? Sorry, Energy Efficiency Nova Scotia, as well as
yeah, and a lot of municipalities have been doing that as part of their greenhouse gas inventories as well, determining how much of the spending on electricity and natural gas and other fossil fuels stays within the community versus leaving the community. But generally, no doubt about it, energy costs don't often stay within the local community. Electricity will stay within the province, and fossil fuel spending, over 90% of it leaves the province in terms of local benefits. That's definitely one of the motivations for a lot of municipalities advancing community energy plans.
Mm-hmm.
And then one other question. I know that this is beyond the scope of the study or anything like that, but based on your experiences from the residential kind of scoping and analysis of EV costing, how do you think that might be able to be applied at the commercial sector?
We recently did some work with BC municipalities that was recommending sort of commercial EV ready requirements. City of Vancouver and City of North Van have just adopted requirements for 45% of parking to be EV ready in commercial developments, and they've got provisions there to allow for some of that to be sort of intended for relatively short-term visitor parking, and for others to be there for workplace charging. So you'd allow for high levels of load sharing and load management for a significant proportion of it, while also having some provisions for more dedicated circuits, at least 40 amps, to provide for faster rates of charging for those visitor parking spaces. So I think that's a good practice. I can share both the report we prepared as well as I guess like a press release for City of Vancouver that Gabby, maybe you could distribute.
Absolutely.
But there's definitely good work happening on non-residential EV ready policies that I think it makes all the sense in the world just to adopt simultaneously. I would just say though that residential is the most important.
Perfect, thank you. Mark, I'll turn it over to you just to ask your question.
Sure, I don't really have a question. I just want to comment. You were talking about the total size of the service in a new build, and that it's a concern. And of course, the size of it, everything that scales up has to be paid for somehow. But there's even worse component. What happens is when you, it's certainly here, when you decide on the size of the service, the utility holds back a certain amount of money. And if it turns out after a number of years that you actually didn't consume the amount of electricity that you asked for, then that amount will be forfeited. This is a massive concern to the developers. So imagine that you had put these all in at 100%, and when, of course, once they got going, it never happened that way. It's a very tough thing. The other loads are very able to figure out.
Yeah, and we've heard that, absolutely heard that from the development community with regards to, there's no doubt about it. There's a recognition that if the building does the analysis and identifies the electricity allocation it's going to be needing, and then as part of that, if the utility needs to make infrastructure investments in order to provide that building with that allocation, they do put a deposit system in place that sits in escrow for a 5-year time period. And if that electricity load that the building identified as its requirement doesn't materialize, that deposit goes to the utility to pay for that infrastructure investment. And if it does materialize, that deposit goes back to the developer. So there's absolutely concerns, and that is one of the key issues that created a lot of pushback from the development community on the Ontario Building Code's calculations and requirements on electricity allocations that were provided as part of that. So there's no doubt about it. I mean, I'm really quite pleased about the studies that showing just a lot of the flexibility that's already used in existing modeling and the buffers that are in existing modeling to try and address the fact that, you know, how do we phase this in? Like, what is the acceleration in terms of actual EV charging that is implemented and used within that first 5-year time period? And what is likely to materialize beyond that 5-year time period? Because they shouldn't be penalized for something that they know is not necessarily going to occur in that 5-year time frame with a deposit. It is something that is going to be a huge issue that we need to kind of work out across the municipalities. I can say one thing in the sense that the consultations that we've done thus far with the utilities have identified that they do not pay attention to like the electricity EV charging requirements. They only want to know what is the building going to need as a whole. And that's what they base their decisions in terms of the infrastructure that they may or may not have to invest to provide that building. So the utilities are unlikely to be providing guidance to the development community on what is the case. Hence the reason for this need for this study to provide the developers and the municipalities with guidance on what are the different designs that may be possible for them to consider, and their electrical engineers are going to have to be playing a very significant role in determining what's best for that building per se. Brendan, anything you want to add to that?
Just in BC, once we adopted these EV ready requirements, BC Hydro came and said, because they've got a similar sort of regime, they said, all right, our policy is not going to be to assume that all vehicles will be EVs within 10 years. We'll assume it'll be just 10%. Now, based on Gabby's conversations with utilities, what I understand is that they will just be sort of accepting the engineers for projects statements. I don't know if that will wind up actually being their policy. So maybe, you know, just as a best practice, engineers could be provided with guidance in terms of what percentage to assume within 5 years of EVs will materialize. I don't know if 10% is the right number or not. Maybe it's 5, maybe it's 20, but it's unlikely that, you know, 5 or 6 or 7 years from now, all the vehicles in parking garages will be electric, although a rapidly growing percentage of them will be.
Perfect. It is definitely put on a flag of some future discussions and consultations that need to take place, which brings us to our next steps on this one. Oh, one other thing I did want to kind of highlight. There was one question that was relating to comparisons on GHGs related to biofuels, biodiesel versus electric vehicles. I don't know if you have any data that you know where we would kind of look at in terms of, you know, the oh, you got it in there, that one.
Yeah, I mean, I would just say, Matthew, if you're still on the line, that electric vehicles, even in Saskatchewan, where right now there's, you know, a relatively carbon intensive grid, are outperforming gasoline and biofuel vehicles in terms of their carbon emissions. So just because they're so energy efficient, EVs are, they perform better than vehicles that have gasoline or different blends of biofuels within them. There's going to be real limits in terms of the sustainability of biofuels. Like, we also need land for food, of course. And so providing all this land to just kind of blend in a couple of percentage points of biofuels into our fuel supply is definitely problematic. EVs are going to provide a lot more sort of sustainable outcomes. And the grid and GHG intensities of Saskatchewan's grid and Alberta's have dropped significantly just in the last couple of years, and they're going to continue to decline into the future as coal is phased out and as we get more solar and wind onto the grid. So even if you're powering an EV by natural gas and some coal, it's going to perform a lot better than a gasoline vehicle. But we're going to increasingly be having renewable supply with some gas and a rapidly declining amount of coal on Saskatchewan and Alberta's grid.
Perfect. Thank you, Brendan. So I just wanted to give a little bit of highlights on this one. We are recording this webinar. I will be sharing the recording, sending it out all to you via email along with Brendan's presentation as well. Just in terms of the next steps on this one, we will be doing consultations. We're compiling the feedback we've received thus far from the utilities, from the developers, from the municipalities. We're going to be coming back and sharing a little bit more of a collective kind of consultation on this in the fall, early fall on this one, to report back to you on the different feedback we've heard from each of the different stakeholders and next steps on this one. We will be doing internal municipal consultations on identifying the pros and cons of using your bylaws and zonings and parking requirements, and possibly using your green development standards should you have them. What would be the pros and cons of those different approaches, and kind of pulling all that information together. And then also one of the key things that I wanted to kind of highlight as part of this is, like, if you have additional questions, please just send me an email so that we can keep that this isn't the only kick at the can. There's an ongoing process as part of this. So if additional questions come to mind, never be shy, just send me an email. So we can compile that and make sure that we address that around the collective input. Just in the terms of time, thank you so much, Brendan, for doing the presentation on this. Really appreciate it. And thank you all for joining us. And if you have any additional input, questions, or anything like that, don't be shy. Please just send me an email, and then we will follow up with you very shortly, sending out all this information. Please share it with others in your municipality. Don't be just forward it on to others who you think may be interested in this as well. If there's others who you also think would be interested in maybe not participating in this haven't participated in this webinar, send me their email address. We're compiling an electric vehicle EV ready contact list that we can keep in the loop on future actions as part of this. So thank you so much, Brendan. Thank you all to all of you for joining us, and hope you all have a great day.
Thanks all. Take care.
Thanks. Bye-bye.